When a small team deploys one application, the delivery process can look simple. One repository, one pipeline, one environment. But at large scale, the problem changes. Now there may be hundreds of services, many teams, many Kubernetes clusters, and several environments like development, staging, and production. If every team changes production in a different way, nobody has a clear source of truth. That is one reason large engineering organizations care about GitOps. GitOps is not just a trendy deployment word. It is a way to make production change more visible, reviewed, repeatable, and easier to recover from. In this video, I will explain GitOps without making it sound more complicated than it is. First, we will look at the delivery problem that appears when software teams grow. Then we will define GitOps in plain language. After that, we will walk through the top-level delivery flow from code change to production sync. Then we will explain why large teams use this process. And at the end, I will show the warning. GitOps helps delivery, but it does not replace testing, security, ownership, or engineering judgment. Start with the real problem. At small scale, a developer can push code, a pipeline can deploy it, and the team can usually understand what happened. At bigger scale, that simple story becomes harder. Different teams may deploy in different ways. Some changes may happen through pipelines. Some may happen through manual commands. Some may happen directly inside a cluster. And later, when something breaks, the team has to answer basic questions. What changed? Who approved it? Which version is running? Is production matching what we expected? This is where delivery process becomes engineering work. Large-scale delivery is not only about moving faster, it is about moving with control because uncontrolled speed creates outages, confusion, and recovery delays. GitOps gives the team a clear operating model. The desired state of the system lives in Git. Desired state simply means the version of the application, configuration, infrastructure, or Kubernetes objects that the environment should be running. Instead of treating the live cluster as the main place where truth lives, Git becomes the approved record. A change is proposed in Git. It is reviewed. It is merged. Then a GitOps controller watches Git and compares the approved desired state with the live environment. If the environment is behind, the controller syncs it. If someone changes the environment by hand, the controller can detect that drift. The important idea is simple. GitOps moves the control point from hidden manual action to reviewed Git history. Here is the top-level delivery flow. A developer changes application code. The CI system builds and tests it. If the tests pass, the build produces an artifact, usually a container image. Then the deployment configuration is updated in Git. That might be a Kubernetes manifest, a Helm values file, or another environment configuration file. The change is opened as a pull request. A reviewer checks it before it is merged. After merge, the GitOps controller sees that the desired state has changed. The controller compares Git with the live environment. Then it applies the approved change to the target environment. For example, staging might update first. Production might require another review, a policy check, or a manual approval before sync. So GitOps does not mean everybody blindly deploys everything instantly. In serious teams, GitOps usually means the deployment path is visible, controlled, and auditable. Now the important question, why do large teams use this kind of process? First, it creates one clear record of operational change. If production changed, there should be a commit, a pull request, and review history behind it. Second, it makes environments more consistent. The team can use the same pattern for development, staging, production, and multiple clusters. Third, it helps with drift. Drift means the live environment no longer matches the approved configuration. At scale, drift is dangerous because two environments can look similar but behave differently. Fourth, rollback can become clearer. If a version causes problems, the team can move back to a known good state in Git instead of guessing what manual steps happened. Fifth, GitOps can reduce direct production access. Instead of many people needing permission to change a cluster by hand, the approved path can go through Git, policy, and a controller with limited permissions. That is why GitOps is attractive for platform teams. It gives many application teams a shared delivery lane without giving every person unrestricted production control. But GitOps is not magic. This is the part beginners must understand. GitOps does not make a bad change safe just because the change is in Git. If the tests are weak, bad code can still move forward. If reviews are rushed, dangerous configuration can still be approved. If secrets are stored badly, GitOps can make the mistake easier to repeat. And if monitoring is poor, the team may not notice quickly when a deployment hurts users. Production GitOps needs guardrails. Use automated tests, use branch protection, use policy checks, protect secrets, limit what the controller can change. Watch deployments with metrics, logs, and alerts. For higher risk changes, use staged rollout, canary release, or manual approval. The goal is not to remove judgment. The goal is to make good judgment easier to apply every time. So here is the simple mental model. Big teams use GitOps because delivery at scale needs a reliable control system. Git becomes the approved source of truth. Pull requests make changes visible. Controllers keep environments aligned. Drift becomes easier to detect. Rollback becomes easier to reason about. And production access can be controlled through a safer path. But GitOps is only one part of strong software delivery. You still need good tests, reviews, security, observability, and ownership. If you remember one thing, remember this. GitOps is not just deployment automation. GitOps is a reviewed, Git-driven way to keep live systems close to the state your team approved. If this helped, subscribe for more practical cloud, Kubernetes, and platform engineering explainers.